Hi, and welcome to video 4 for section 9.1. This is the fourth of the 4 videos. I've given you guys a ton of information in the first 3. It's all kind of been building on each other to get us to this grand spot, which is using vectors to model velocity and force. This is a big time favorite problem for the final exams. So it'll be on your exam 3, it'll be on the final exam. It has to do with the kind of problem where either like a plane is flying and getting pushed by the wind, so we want to figure out what's the plane's actual velocity, what its true velocity, what its heading is. It's also going to be, it's the same kind of problem as like salmon swimming in an ocean and there's a current pushing the salmon. So when the salmon swims, how far is it actually moving? That's the kind of problems we're going to encounter. That's the problem we're going to look at just in this video. So come exam 3, come the final exam, you'll want to, if you can bookmark the videos or highlight which ones you may want to rewatch in the future, this is going to be one of them because this is the exact kind of problem you're going to get. So let's look at an example of what kind of problem we're talking about. So we have the following. An airplane heads due north at 300 miles per hour. It experiences a 40-mile-an-hour crosswind at a direction of north 30 degrees east. So this relates back to our bearing and heading problems. So this notation, north 30 degrees east. So we have 3 problems, or 3 questions we want to answer. First, we want to express the plane velocity relative to still air and wind velocity in component form. So component is our AI plus BJ form. Again, this specific problem is talking about an airplane with wind. It could be rewritten as a salmon swims due north. It experiences a current of 4 miles an hour north 30 degrees east. So the problems may change in terms of like plane or salmon or boat or whatever, but the idea is going to be the same. So if you can understand how we work these problems, once it's switched up to be a plane or a salmon or whatever, is not going to be an issue for you. So that's the first thing we want to do. The second thing is we want to find the true velocity of the plane as a vector and then third, we want to find the true speed and direction of the plane. So let's think about what these 3 pieces are asking. First, we want to express the plane velocity relative to still air. So that's a saying that if this plane was just flying in a vacuum, there was no headwind, no tailwind, no side wind, crosswind, anything, how fast is, or what's the velocity of this plane. The second part is the wind velocity in terms of, in component form. Sorry, I should have component form here. So the wind by itself. So we're finding out both separate pieces. Why are we doing that? Well, remember, with regards to vectors, we can just add together vectors to give us what the overall displacement is. And that's what number 2 is doing. So once we figure out number 1, the plane by itself, and the wind by itself, then we add them together. That gives us the true velocity of the plane as a vector. And then finally, in number 3, we're determining what's the actual speed of the plane. Is it more than 300 miles an hour? Is it less than 300 miles an hour? Is it still just 300 miles an hour? And what is the actual direction of the plane? So it's flying, but it's getting pushed by the wind. So what is its actual direction? All right, so if you haven't written this down, go ahead and pause, get it written. I'm going to erase it so we have the whole board here to work out the individual parts of this problem. All right, so let me switch colors here so we can keep track down the road. So the first thing we wanted for part 1 was the velocity of the plane in still air. So what was happening with this plane? It was at some starting point. It was flying due north at 300 miles per hour. So that means what? If I'm going to write this as a vector in component form, so again, that's AI plus BJ. So the I portion is how far am I moving left or right? And the answer is 0. I'm not moving left or right at all. But how far am I moving up or down? Well, I'm moving 300 units up. So plus 300J. So that's the plane by itself in still air. Now the wind, it tells us, is at north, which would be facing upward, 30 degrees to the east. And that was at 40 miles an hour. So my angle inside of here is 30. But remember, what is the AI BJ talking about? So I want to know my displacement from my starting point, how far left or right, and then how far up or down. So that's my A and my B. So that means what? This angle in here would be 60. So now we can use our triangle shortcut, or you can use your trig function. So if we use, from video 3, our horizontal and our vertical components, if we don't have this triangle here, we have what? A is the magnitude of V cosine of theta. And B is the magnitude of V sine of theta. So my angle inside of here is 60 degrees inside the triangle. So my A is 40 times cosine of theta, so cosine of 60, which is 40 times a half, which is 20. Which again, you can see we have our triangle, so this is 30 degrees up here. So A is the short leg from the hypotenuse, so we know that that's what? 20, and then that means using our shortcut, this is what? 20 square root of 3. But if we don't know the triangle shortcut method, and if we do the vertical and horizontal components, then B is just 40 sine of 60, which is 40 times square root of 3 over 2, which is 20 times square root of 3. So the plane's vector and component form is 0I plus 300J. The wind is going to be 20I, so it moves 20 units to the right, and plus 20 square root of 3J. Moves us 20 square root of 3 units up. So obviously on your exams, you're not going to have a calculator to calculate these values, but because we're going to want exact values later, I'm going to rewrite this as 20I, and 20 times square root of 3 is 34.64. So we'll have that as our wind component. Okay, so now that's question 1. Plain and still air, wind as a vector. Question 2, we want to know the true velocity of the plane. So if this plane is taking off, it's heading 300 miles an hour north, but then what's happening? It's also getting pushed over because of the wind. So let's call our plane U, let's call the wind V. So this is U, this is V. So then this guy here, the dotted line, let's call him W. Well, what do we know about vectors? That we can just add them together and that gives us the other components. So before, what did we have to do? We had to do law of cosines, figure out a bunch of angles, do square roots, things like that. Now that we have vector notation, we don't have to worry about it anymore. All we just have to do are add the two vectors. So the true velocity of the plane as a vector is just the combination of these two. So 0I plus 300J plus 20I plus 34.64J. So all we have to do is basically combine like terms. Add the I pieces, add the J, so we get 20I plus 334.64J. So that, excuse me, that is the true velocity of the plane as a vector. So that's question number 2. So lastly, question 3, we want to know what's the true speed of the plane, which is what? Magnitude. What's the magnitude of this vector? And then also, what is the heading of the plane, the true heading? So it's not really flying due north, it's getting pushed over a little bit towards the east. So the true speed is just the magnitude of W, which is what? The square root of 20 squared plus the 334.64 squared. Remember, that's how we find magnitude of a vector. Square root of the two components and add them together. So that means that W, the magnitude of W, the magnitude of that vector, is approximately 335.2 miles per hour. And this is something you're used to. Like if you're flying from California to New York, and if you're flying into a headwind, it takes a lot longer than coming from New York to Los Angeles when you have a tailwind. The plane might say 500 knots, or whatever, 500 miles an hour, but in actuality, you're getting that push or you're getting that slowdown from the wind. So that's what's happening here. The plane says it's going 300 miles an hour, but because of the push from the wind, it's actually going 335.2. All right, now we need to figure out what's the heading of this plane. So let me draw this picture a little bit bigger here of what we got going. So we have this line here, that's our length of W, which is 335.2. And then what are the components of W? Well, it's 20I, which means we have 20 down here on the bottom of this triangle. And the vertical is what? 334.64. So I want to know the actual direction of this plane. So what I really want to know is, if it were to take off and start flying this, what is this angle in here, the real tiny piece? But to first find that out using this vector notation, and the values I have, 20, 334.64, and 335.2, I can first find out this value of theta, and then just take 90 minus that value to get what's the actual degree measurement, and then of course I have to put it in heading notation. So to figure that out, what do I have? I have the tangent of theta is opposite over adjacent, so 334.62 over 20. So that means the tangent of theta is approximately 16.732, which means that theta is about 86.6 degrees. So you're just going to do 334.62 divided by 20 on your calculator, do tangent inverse of that value, should give you, excuse me, 86.6 degrees. But that's the blue angle, the blue theta. I want the red. So what do? I have to do 90 minus 86.6, which gives me 3.4. So the red angle is 3.4 degrees, but as a heading, how do I write that? Well, what is it doing? It's going north 3.4 degrees towards the east. So my actual heading is north 3.4 degrees east. So that's the 4 points of this problem, or the 3 parts, but all the different points of it. First, plane and wind as individual vectors. Then combine them to get the velocity of the plane as a vector. Take the magnitude of that vector to find out what's the true speed of the plane. And then figure out what's this value of theta so that I can actually get the heading of that plane. So that's it. That's video 4 for 9.1. That's the last of the videos. Again, this one is the velocity of a plane, a salmon, etc. So come on back. We'll see you in video 9.2.